Can everyone hear me, including the people at the back, who are my prime audience? G'day Josh, how you going mate? And everybody there. I don't usually use a microphone. I've got a strong voice as it is, but if this works and isn't too loud at the front, that's excellent. Thanks very much for inviting me to talk. I surprised Jan at the front when I walked in, A, very early, and B, she didn't realise I'm actually a member of the RGSSA. Now, one thing I don't know, I was sitting there thinking, I'm not sure, are there any other members of the Royal Geographical Society in Mount Gambier, where I live? So maybe I'm your Mount Gambier representative. I guess we'll have to check the membership, won't we? Yeah, there's probably a few around the place somewhere. Some of your faces tonight I recognise from the Field Geology Club and the Geological Society and so on like this. It's lovely to see everybody here tonight, especially with that howling cold wind that we've got out there. Normally when I give a talk, and I've given hundreds of them on a range of different themes, I just whack up the slides and go because it's all in my head and I know what I'm talking about. Tonight's talk's a bit different. I don't ever rehearse talks, but I have rehearsed this one a bit because there are a number of quite serious messages that come out of it, and it's not just a happy snapshots of volcanoes and sinkholes and so on, although they are in there of course, but those features are wrapped in this conundrum that Lee's referred to about the original Kanawinka Geopark and what's happened since and so on. I was very interested to see that little bit of movie that you had before about the society. As a geomorphologist, I got it, but as a member of the society, I understand also why we're all members of the Royal Geographical Society, and I thought that little movie expressed that. I think you'll find considerable overlap in the approaches and the philosophies and the motivations of your society with the World Geopark movement, which is not really surprising. So we'll proceed through to talk about this evening. I'll give you a bit of an introduction about the UNESCO Geopark program, but very short at the beginning. Then I'll take you on a trip through the various important segments of the Kanawinka Geopark as it was, and of course the land hasn't changed, so it's still all there, which we go and see when you have field trips down there. But then at the end of the talk, I'll wrap that up in a broader context of talking about that was the geopark, what have we got now, what's happened in between. And so that I felt that the Royal Geographical Society is one of the most appropriate bodies to give this message, which I haven't really done before. So I've chosen you as an audience and a society to lay out a range of this information which I've been gathering for many, many years, so that you can understand as well, and that might provoke quite a range of discussion, not just after I talk tonight, but ongoing. So Lee's already introduced the topic there. I am a hydrogeologist. I work for the Department of Environment and Water. I'm in their groundwater team. So they deal with underground water all over the state, drilling for water and all the things that do with it. All of the team is in Adelaide, where I was for 10 or 15 years or something. After COVID, I asked to transfer down to Mount Gambier, where I grew up, and there was an empty desk down there, so I'm the hydrogeologist in the southeast region. So that's my background, and that came from my geomorphology studies, which as Lee referred to, specialised in limestone karst areas, and my professor was Twydale as well, so I learned a lot from him. I'm very grateful for that, and I've been able to apply a lot of that cave exploring as a teenager and cave diving for 40 or 50 years, all that knowledge and my geology and groundwater knowledge into understanding the region, which is why I've ended up in the role involved with the Kanawinka Geopark and subsequently. Now, this one, the big one, oh, look at that, fabulous. I feel more comfortable. Oh, what are they then? Okay. I could give a whole lecture on the UNESCO Geoparks, but really I want to talk our geopark and the background that's happened. This was a map of UNESCO Geoparks in 2020. There's a couple more since in Southeast Asia. Oh, sorry, is that too loud? No, okay. In Southeast Asia, there's been a few more, and one in New Zealand. But it's interesting when you look at that map, there's a whole lot in Europe, a whole lot in China, Korea, Japan, and as I said, now more in Southeast Asia. Indonesia's got about 10 now. And when you look at Africa, there's only 2, South America, a couple, North America, only a couple, and 3 places particularly, no, 4, where there are no geoparks. India hasn't got any. The whole of the Soviet Union, but who knows what goes on in there. The United States has no geoparks, and neither does the entire continent of Australia, where it used to have one. So I'll talk about that situation as we go along. Bits of information as I show you the geopark, but it's the end of the talk where we'll get to grips with that. But just out of interest, which is the little shiny button? The big one. No, it doesn't want to do it. Okay. Kanawinka Geopark spans the South Australian Victorian border of the whole of the limestone coast region, or no, a fair bit of it, I should say, across the Newer Volcanic field, which are the volcanoes all the way through to around about Ballarat. Now, let's try that.
Sorry, the big button.
The big button. Oh, right, yeah, okay. Right, thanks, Lee. Yeah. So we'll talk about Kanawinka Geopark. Oh, there we go, map on the far left-hand side. You can see that corner of the nation, spanning the borders there. That was one of our posters at the time. On the right-hand side of the poster I did with a gentleman called Professor Bernie Joyce. Some of you might have heard of him. He's a wonderful guy in Victoria who had been promoting geological heritage his whole life. Died a few years ago, and terrible loss, but he and I put together that poster on the right. It's in 3 columns. The column on the left is about the volcanics. The column on the right is about the limestone and groundwater. The column in the middle is about the human activity on the landscape. The reason why I mention that is they are the 3 main components of geoparks then and ongoing. We sometimes summarise it as the ABC of geoparks. The abiotic, which is geology and landforms. B for biospheres, botany and so on, and C for the cultural input, which is the human level of activity on a landscape. So that's what that poster was showing at the time. There we go. This is a geology map of Western Victoria and the southeast of South Australia. You can just see where the border is up there. There's a couple of remarkable things about this map. A, that it exists. You have to find the right book where it's shoveled in the back in a pile of maps this thick, but it was done by a combination of the mines departments of Victoria and South Australia in the 1960s when they were exploring the whole of that offshore area and onshore Otway Basin for oil and gas. And it's the only time the 2 states combine in this huge project where the geology maps were done together so that they match. Otherwise, all the other geology maps, where you join them at the border, you think you're talking about different planets. The colours are different, the lines are different, everything else, just like state governments. So this is a fabulous map, and it actually covers virtually, it does. It covers the entire Kanawinka Geopark, which is that lower southeast area, and that large area across Western Victoria, which is in various shades of pink. The shades of pink are the lava flows and the vast amount of lava areas that flowed out across Western Victoria. Huge amount of that volcanic activity. And the darker pink zones are where lavas have flowed or spread in different directions, and in particularly in the middle, you can see where they've headed down old river valleys and gone out to sea. Some of these lava flows are over 100 kilometres long, just pouring out of one volcano. So there's been a massive amount of volcanic activity in Western Victoria. And Mount Gambier is that little pink circle over in the lower southeast there, far smaller, didn't have, well, not part of the big lava flows like to the east, but it's deceptive because to the northwest of Mount Gambier, there's a couple of tiny pink dots. You just might be able to make them out. Well, that's the 12 volcanoes on Mount Burr range, but they're nearly buried. And the pink dots are just a little bit of the volcano sticking out of the top. They've been buried by sand dunes in the various ice age phases. So there's a lot more there than this map shows. So I'll take you on a fairly short trip on, just cherry-picked a couple of the volcanoes across the Kanawinka region. That could be a series of lectures on its own. We'll just keep it brief because we've got other things to cover. I've put in that term Volcano Discovery Trail because this is how it all started. Somewhere around about the year 2000 or thereabouts, tourism people in Western Victoria were trying to find a way to get tourists who go to the Great Ocean Road to stay there for a while and come inland and look at the volcanoes as well and bring their visitors and their money and so on into that area. Alternatively, visitors who went to the Grampians would come and stay in Western Victoria. So they identified that this whole volcanic region is between the Great Ocean Road and the Grampians. Can we keep people in the middle? We've got something that's just as good as those, just as special as those places. So they had a thing called the Volcano Discovery Trail and a map and various things like that. The idea of nominating the Volcano Discovery Trail in that region to become a UNESCO Geopark came from a number of different people in the eastern states. They had a series of meetings across Western Victoria to canvass this idea, and they came to Mount Gambier, and I went to the meeting. And nearly as many people at that meeting as there are here tonight. And everyone got really excited about it, and I stood up and said, if you're talking about this thing called a geopark, you're standing in a huge amount of limestone, caves, fossils, everything else and so on. If you're talking about geology, you can't ignore all of that. And most of the Victorians said, oh, what limestone's that? So we educated them a bit, and I joined the committee on that day and got involved with the nomination process. Let's have a look at some of the volcanoes, but I'll skip through this fairly briefly because we've got to cover some more information. This is a map done by Bernie Joyce in Victoria and University of Melbourne. All those dots are volcanic sites of one kind or another. There's about 400 of them. The blue dots are ones where volcanoes are blowing up through the water table, which affects the shape of the volcanoes and how they explode, particularly at Mount Gambier, which we'll see later. The orange triangles are dry volcanoes. That is, they haven't intercepted water on their way to the surface. And the dashed line across the middle is roughly the northern edge of the Kanawinka Geopark zone. It didn't extend up past Ballarat into that central province. Concentrated in this area here, more towards the coast. Some of you have been possibly to Mount Eccles in Western Victoria, and that you climb up the side in a comfortable walk, and suddenly there's this huge long crater with a lake in it called Lake Surprise. It's a linear volcanic vent. In fact, there are still gas bubbles coming up through the lake. We've done a dive in there and it's all a bit funny down there, so maybe it's still sleeping. The photograph on the right is taken from Iceland, and it's a fault line in Iceland where lava is fountaining up in a long line, which is precisely how Mount Eccles or Budgebim formed in the first place. And if you look at that diagram on the right, you see that towards the end of where the lava fountains are, there's a lava flow to the right, but also just the beginnings of a crater cone forming. And so that's how Mount Eccles would have formed. So the landscape on the right would have been somewhere just south of Hamilton 30,000 years ago. That really would have arrested the attention of people living there at the time. this is more typical of the volcanoes across this whole region. They're called monogenetic. That is, they tend to grow in one spot, then they go to sleep and they become extinct. They don't keep firing up like Vesuvius does and Mount Etna and so on. So they build up into a mound like this. This one's at Camperdown, the Sugarloaf Hill. This is Mount Elephant, which is a bit further inland. It's called that shape because if you look at the bottom photograph, there's a bit of imagination. It's like a giant elephant lying down. And it's the highest volcano in that region in the middle of a vast plain. So early settlers and no doubt all the First Nations people could navigate their way around by seeing this particularly shaped mountain. It used to be called the Lighthouse of the Inland. You can see in its wall on the on the bottom photograph where a quarry's been quarrying away at that and left a bloody great scar on it. Probably unfixable. This is, if you live in Hamilton, you call this Mount Napier, but the rest of the planet would call it Mount Napier. So I'm on my best behaviour in Hamilton. Don't know why there's a difference in pronunciation. Big volcano up there, one of the biggest ones in Western Victoria. It was a shield volcano of lava and then blew up through the top as a crater. And this valley is called the Harmon Valley, and this is a pathway where Mount Napier disgorged this 100-kilometre line of lava, just pouring out endlessly from the volcano, flowing all the way down, and it's formed the foreshore platforms at Port Fairy. So when you go to Port Fairy and see that dark rock where the waves are, it's the other end of this process. Some of the lava flows were much older. I showed you on that original geology map. You can see here, if you look, the eye picks out a couple of different bands of lava laying on top of one each other till you get down to the broken stuff at the bottom. This lava is going a long way back, over 2 million years, and that's the ledge of the Wannon Falls near Hamilton. And the lava, in that case, in a number of huge flows, came down the Wannon River Valley as the line of least resistance, filled it up with lava, and then when that was all over millions of years ago, the Wannon River just said, rightio, well, I'm just going to keep wearing away, and there's a gorge all the way up to here where you can see the lava's been worn away for several kilometres, but it's a long, slow process. This is that round mound there is a tumuli, or if you like, we can call them a volcanic blister. This was caused by lava pouring out of one of those volcanoes down one of the river valleys, but in this case, so much lava was racing down the valley at the speed of water, it was quite very, very runny, that this valley here, which was a little tributary stream, the lava pushed back up the stream because there was so much pouring out and filling it, and in that back pressure forced these giant bubbles to form. So it would have been like giant red hot glass bubbles, you know, maybe 5 times as big as this room and higher. When they finally cooled down, they start to crack and so on. They kept their form and so on, but all those big boulders, if you could pack them together like a jigsaw. There are other tumuli around the world, but ours apparently are by far the biggest. So there we go, we've got the big tumuli. This is Lawrence Rocks, near just offshore from Portland. You can see a peninsula over there, and that big building is the Portland aluminium smelter. Town's behind it. You can see a circular bay in front of the smelter facing this way, and a circular island. That circle is one gigantic crater. And if you think that's big, you look in the way in the distance, there is another half circle. That's Bridgewater Bay, which is about 5 or 10 times bigger, and it's an even bigger crater. When we go diving off Lawrence Rocks, this is what it looks like under the sea, and you can see all of there in that light blue area, submerged volcanic cones that you can dive on and in craters and so on, and all that's hidden by the rising sea as the ice ages melted and so on. The last of my volcanic sequence is Nuns Beach at Portland, where lava is lying over limestone. So this opens up the whole vista across this region. But limestone is much older than a lot of the volcanics, and the volcanics have overlain it, and there are a lot of fascinating interactions between the two. So we'll now look at the limestone. And this is, of course, why I got all excited at that meeting and said to them, you can't forget limestone if you're going to have a geopark. So there's, you can see the limestone in the background there in the Narracourt Caves, that beautiful sort of honey colour. 30 million years old or so, the seafloor at the time that formed that before the land, the land was lifted up above the sea levels. We've got lots and lots of limestone in Victoria, and this is, of course, all the Port Campbell area. So when I now realise, in fact I did a long time ago, once this tourism thing got going, people didn't want to know about the Great Ocean Road. They wanted everyone to come and look at our volcanoes in Western Victoria. So there's a bit of argy-bargy between the tourist centres and the different councils and things like that. But anyway, vast amount of limestone along that whole Port Campbell coast, and there's more limestone. And that's the biggest slab of limestone we've got on the planet, the Nullarbor, that's our side of it. Why is it all there? Because when Australia broke away from Antarctica, and they're moving apart, they're not clashing, the seabed of the Southern Ocean began to develop as the Southern Ocean filled the gap between the continents. And as Australia's moved forward, the top end, the north end, is banging into New Guinea and Indonesia, which is why we've got all those volcanic and earthquake areas, like the front end of a bulldozer. And the back end is lifting up, which is the southern coastline, exposing the seafloor. There's a map of the limestone area we'll talk about for the next few minutes. That's the limestone coast region. That's a map taken from the Geological Society of Australia, the South Australian Division, and those special numbers and codes are something that was commenced in about the 1960s, that our state division decided to nominate places that had special geological significance and list them. So they used to call them geological monuments. Now we call them geological heritage sites. But one of the advantages of that is that under the planning laws, if one of these sites comes up under an area that's got to be subdivided, there needs to be consultation about the geological feature, whether it's a cave or a granite outcrop or a cutting or whatever it might be, to preserve its importance. So our state division being the forerunner of this in the Geological Society in Australia, there's about 400 of these across the state. So here's a photograph of what's happening under the limestone in the southeast. You can go along the road there where the telephone pole is and just carry on with your life and do everything on the surface. Who knows what's underneath? This is a quarry near Narracourt where they worked their way through until they intersected this really large cave developing. So they'd be quite typical of where there are areas where caves are developing beneath the surface of the limestone, because they develop from below and work their way up. In this photograph, where the two blokes are standing, the groundwater has weakened the area there until that huge band of limestone just sags as it breaks. It's created a little shallow cave at the top, but eventually that'll all break down into rubble. After a long period of time, 10, 100,000, 500,000 years or whatever else, when the collapse occurs and groundwater dissolves the rubble, you get this. So this is the same shape of cave without all the rubble in it. It's just got lots of people in it. And this is Blanche Cave at Narracourt. And so the erosional processes going on under the ground can develop different circumstances. Blanche Cave is very popular. It's been used for dances and weddings, parties, everything for 100, 150 years. And then across the landscape, a bit further down in the Mount Gambier region, we have these famous sinkholes. So they are indication that large caves are forming deep below and they're sinking in to the spaces that are being generated down beneath. These ones look like they're in a bit of a curve, but they're not really. They're in a zone that runs almost directly towards Mount Shank there in the distance, volcano, and there's another 3 or 4 sinkholes like this, quite big and deep between us and the mountain, and another dozen behind us. So we're in a zone full of them. This is one of the most famous ones, and I'm sure some of you have been to Umfeston's cave at the east end of Mount Gambier. Umfeston was one of the German settlers who came in the 1860s and 70s, bought this property and decided he wanted to create a European sort of garden there. That's been maintained. There's been a few people who have said, well, why don't we get rid of all of that and put native vegetation in it? And the community says, hell no, this is part of our culture too. There's been European settlement, in this case German settlement, and so on like that. So there are different ways to look at these things, and there are other giant sinkholes around full of native vegetation, so we have a selection. Up on the top left-hand of this diagram, you see Hell's Hole, and next to it is Umfeston's cave. So where I was a minute ago, there we go, you can see it's really big there, with the steps down the bottom and all the rest of it. But when you compare Umfeston's cave to the other sinkholes, they're all drawn at the same scale. You can see Umfeston's actually not all that big compared to what else we've got. So I've got Hell's Hole next to it, which is twice as deep, and the black areas are the underwater tunnels, and several other sinkholes, including the Little Blue Lake on the left, which is about twice as deep as Umfeston's cave and so on. So that gives you an idea of the sinkholes, and then the one on the right, this huge one called the Shaft, is drawn at the same scale. So if you thought the sinkholes on the left were big, this is a monster. But one day, somewhere around the top there where that tiny little hole is, parts of that rock will fall in 10,000 years from now or sometime, and it'll start to block off those big tunnels, and it'll start looking much more like one tree sinkhole over there. And so what that tells us is when we look at One Tree and Little Blue Lake and Hell's Hole, they've probably got massive great passageways like this that are now blocked off and we can't get to them. So people like Josh over there wriggle through all the little holes and try and find our way into the mystery tunnels. And I want to give credit here to my mate Pete. Where are you? There he is. Pete and I have worked together for most of our lives, and we got really interested in these sinkholes in the 1970s after some of those cave diving deaths when people didn't know what they were doing. And we said, we need to explore and map these. So these maps are the result of Pete's work and mine and the team that we worked with, which allowed people to plan and deliver a lot more safety for people diving. But interestingly enough, it also has opened our whole world of understanding of what the groundwater does under the region and where does it go and what effects is it having. So the divers, cave divers, have been able to contribute significantly to limestone and underground water science in the southeast region. And one of the things that we didn't know 50 years ago, but we do know now, is those green dots represent most of the large sinkholes, or along the Tartwalk fault line, the middle one, the green dots are complex cave systems. And up at Narracourt, you can see all those caves are clustered together. But when we put all the maps together and had to think about it, we'd done all our research over many years, we realised that they align along the 3 huge fault lines of the limestone coast region. So those purple lines are fault lines. There are many other fault lines, but they do not reach up to the limestone and come to the surface. They've been buried by the ocean floor, but these 3 are strong enough to have broken up through the limestone. And those fractures, those huge fault lines, give pathways for groundwater to move through to help dissolve sinkholes and things, for volcanic gases to come up, and for lava to come up and explode in volcanoes. And you can see where the orange triangles are, that's where the volcanoes are as well. And so as a result of geological work and our cave diving work and mapping and a whole range of other things, cave exploring, we're able to start to see the synchronicity between volcanoes, limestone and groundwater that make this region what it is. So this is all the western end of the Kanawinka Geopark, and by the time when we were starting to explore these things, everyone who was taking notice of the geopark realised how significant our end of it was not just the volcanoes. So we'll talk a little bit about the groundwater for a minute because it's the third major agent in the landscape. When we talk about geology and geomorphology and landscape formation and so on, apart from rivers, people don't think of underground water and what it can do. Well, it's done a lot of things. So this is Little Blue Lake Sinkhole. I'm sure many of you would have seen photographs of that. That lake in there is the level of the groundwater stored in the limestone. And the limestone is 100 to 200 metres thick in this area, and it's all water. And that's not the only aquifer. But when you can see a couple other things in this photograph, the sinkhole, and there's Mount Shank over there. That lone pine tree in the top right-hand corner marks another sinkhole. So here's another part of this alignment between the sinkholes and the volcanoes. We've never worked out why they called it one tree sinkhole. But another interesting aspect about this is where we start to bring in this cultural or human engagement with the landscape, apart from the roads and the paddocks. If you look to the opposite side of the lake there, there's a ramp that's been cut in the limestone heading down towards the water with a cliff below it. That ramp was cut somewhere by hand with picks somewhere around about the 1880s or thereabouts. We don't know when. You can see all the pick marks. And then they stopped at that ledge. But then in those times, the groundwater level was that height. So stock could walk down and drink. And in the last century, as rainfall's been going down, so has the groundwater level, almost exactly the same. And now even a giraffe couldn't drink if it walked down that ramp. So there's more to be learned from these natural features than just what they appear. No surprise, of course, you would have all heard about the delight of cave diving and sinkhole diving down at Mount Gambier, the clear water, the size of them, the sunlight coming down and so on. And of course there are other cave tunnels as well. On the left is a big canyon of Piccaninny Ponds. And you can see the white limestone, how it's been shaped by water dissolving it, slowly moving through the limestone. And on the right is a beautiful shot of a diver with sunlight streaming down in Kilsby Sinkhole, which is available to the public for snorkelling and things like that. Beautiful fresh water, the best fresh water in the country. This limestone coast region in terms of water is probably the most blessed in Australia. Here's the city of Mount Gambier, and you can see the volcano of Mount Gambier down to the southwest corner there, the big one, the big crater of the Blue Lake, and the slightly smaller crater of the Valley Lake and others. Interesting when you look at the grid pattern of Mount Gambier, the road pattern, when you're in the town you think, oh, that one goes north-south and this one goes east-west, but they don't. They're parallel to the volcano, not to north or south at all, and the volcano is parallel with the fault line. So Mount Gambier is built along a fault zone and it's all lined up with it, which a lot of its good residents don't really realise. And I've drawn a couple of red lines there linking up some of the caves and sinkholes across the city because the whole zone is along one of those fault line zones that I explained to you on the earlier diagram. Let's look at this groundwater as exposed in the surface of the Blue Lake of Mount Gambier. It's the same groundwater as Little Blue Lake that I talked about. It's a bit further inland and the level is just a little bit higher. This is a diagram showing the Blue Lake there, and these different coloured bands are different sub-layers in the limestone. On the right-hand side is the area under the city, and you can see dark blue arrows running towards the lake. That's the direction of the very slow movement of the groundwater. It's been doing that well before humans arrived, and it's filling the lake and then moving on its way. One of the problems, and they've done a sort of diagrammatic version here of drainage bores and caves and sinkholes, is that whatever's washed off the streets of Mount Gambier from petrol stations and butcheries and dairies and all sorts of other sort of rubbish has gone into the ground and into the groundwater. And where is it heading to? It's heading towards the Blue Lake, which they pump out of to drink. So the Blue Lake water is chlorinated, But credit to SA Water, they really keep a close eye on that. They test it all the time. And so far, there's not been any evidence of any pollutants within the Blue Lake water at all, with one exception, and that was in the silt parts of the bottom, which those of us who dive as recovered samples, they found slightly higher elevated microparticles of carbon, which coincide in the last couple of 100 years when Europeans arrived and started clearing the land and burning the old forest. So that's shown in the lake, but not pollution from the city. I'm a scientific diver and I've been quite concerned about this, so I have been working with SA Water, running some diving exploration and scientific trips in the lake in an attempt to find those points where those blue arrows are coming into the lake, so we can put monitors in there and we can have advance notice of any pollution coming through. And I'm thinking ahead 50, 100, 150 years, because hydrologists do. You just got to think, what water have we got? What will it be like? Will the rainfall continue to decrease? Will there be more runoff? All these questions. This is the little boat that we pot around the Blue Lake when we're doing preparation for some of our dives. To a diver, when you look at that clear water, you say, I just want to jump in. So clear and beautiful. But to geologists and hydrographers like Pete and so on, we look at that, and as well as how beautiful it is as divers, we look at cracks in the rock, which is where the groundwater is going to be coming through at some point if we can spot the places. This one on the right, you can see a fracture in the walls above the lake just disappearing into the depths. And we follow that one down to about 50 metres so far, and it just keeps on going, and we're trying to examine it really closely to see if there's any indication of what we call microcurrents of the water. It's not running out like a river, seeping out. We've seen microcurrents in Piccaninny Ponds and a couple of other... okay, that's fine. We've seen microcurrents in one or two of the sinkholes at depth, so we're trying to find them in the lake as well. We've got a new toy to play with. This little remote operated vehicle, which belongs to the SES down there. We've been experimenting with that off the pontoon in the Blue Lake to see if it can do some filming. It can go down to the bottom of the lake in 70 metres of water, and there's about 500 metres of cable or whatever. So we can do quite a lot of searching around the walls without having to put divers in until we've got a target area. So this project's planned to go on over a decade, about once every couple of years, to go and put divers in to look at high risk spots to see if we can maintain incoming water records. But we did find something else over a number of expeditions there. These remarkable things called stromatolites that weren't supposed to be there, and they are. And I've put a yellow ring around which part of the lake we found a forest of them, and you can see me drifting above one there, and that one's about 2 or 3 metres high. And you can see they're growing up like these sort of stumps from the side of the lake in 20 odd metres of water. So a stromatolite is really like a microalgae that grows in the warmer part of the year. Then it dies off and precipitates calcium carbonate crystals, which basically become stone. And then the following year, when it warms up again after winter, the algae start again. So you get these layers in stromatolites. These ones they always point towards the light. The sinkholes are full of them, but not like this. The ones in the sinkholes grow out of the walls like this, heading for the sunshine at the top. So the question is, how did these ever start in the Blue Lake? Because 5,000 years ago, it was an almighty blast and a massive great hole which would have killed everything. So questions about how the algae could have got there, perhaps off birds' feathers or something like that. Interesting about that yellow circle, that's the high impact zone that I predict is where groundwater under the city will come out into the lake as well. It's the only area where these stromatolites grow, so is it possible that they are growing there because thousands of years before humans arrived and the city was built, is it possible that the groundwater is bringing in micronutrients through into the lake, and not pollution, but nutrients, and these things have been growing on them. So maybe nature is telling us something which we're a bit slow to catch up on. So these are elements of the groundwater, which are the third big natural agent that's influenced the landscape, the caves, and it's influenced the volcanic eruptions as well. The groundwater flows through the limestone and comes out through some beautiful springs close to the sea, like Ewards Ponds and at Piccadilly Ponds and a couple of other smaller ones. And that's just the freshest water you could ask for. It's beautiful. And Pete knows this, but Josh, that's Spencer's Pond before the salinity started. So that's a whole other story. Beautiful fresh water. Botanists tell me that there are species of plant that grow underwater there that would normally be land-dwelling plants, but there's enough sunlight and oxygen in the water for them to become aquatic. Okay, I'm moving through, just keeping an eye on my time. Oh yeah. I mentioned that with a geopark, it has fundamentally a geological or landscape base, geographical base, and we've talked about that quite in some detail, but also a biological component and a cultural or human component. So we'll look at these last two a little bit more. I've just picked a few of the creatures from the Kanawinka Geopark, which are extraordinary. I could do a long list of creatures and so on, but we've got fossils of the megafauna and microfauna going back, well, we now know over 1.5 million years at Narracourt, and 500,000 years in some of the caves a bit further south, which we dive in, where we find the bones in the mud. That little diagram in the bottom right-hand corner, Victoria Fossil Cave, is where the huge World Heritage fossil discoveries were made in 1969. That's about 4 kilometres of tunnels that you walk around or crawl in. They're all dry, there's no water in there. But divers have a cave closer to Mount Gambier near Tantanoola. Let's do this. Which we call Fossil Cave, or it's a combination between Fossil Cave and Tank Cave, and it's twice as long as the Victoria Fossil Cave, and they're finding the same fossils underwater in the mud and the silt, where animals have come further into the cave at drier times in the ancient past, needing water and getting trapped. So divers are doing this work too, and there's a big research project going on in a couple of these caves at the moment. And I was on a team that nominated this cave and have listed it on state heritage, so it's protected, so people can't go in there and sort of just grab fossils and things. These are some of the fossils you find there, and I mean the tall ones, folks. That's a diprotodon, a model of a diprotodon on the right, giant sort of wombatty type creature, and Procoptodon, which is the giant kangaroo, was too big to hop. It just reached up and pulled bits off trees that nobody else could reach. So we're finding bones like that. And at the other end of the spectrum, in this whole Kanawinka geo region, one of the other really special species are these little bent-winged bats. They breed in one cave at Narracourt during the summer, and then they disperse to a number of specified caves across the whole of the Kanawinka region into Victoria and down past Warrnambool, where they cluster in the roof and hibernate for winter. And so we've been measuring their weight and all sorts of things like that. When I was a teenager, on my second ever caving trip in 1967, we went to the maternity cave at Narracourt, and the estimate by the museum people at the time was there was 200,000 bats in that one cave in the breeding season. But in recent decades, the numbers are about 30,000. So that's a terrible population crash. Researchers have been finding that the insects that these bats survive on have got sprays in them from over the vineyards and other pastoral areas and so on. So they're now declared as an endangered species. and special research money is available. And the caves where they now go, where they go to hibernate, which we knew years ago, are now protected caves so that they're not disturbed in their winter phase, and they can come back for the breeding season. Here's a bunch of them having a sleep. They look pretty cute, don't they? And if you look at the top, in the middle, there's always got to be a redhead, doesn't there? So that's what they do for 6 months of the year, just all packed together, and yeah, that's right. They hang upside down. Yes, what happens when they pedal, I just leave it to your imagination. Other species, special species in the whole Kanawinka region, southern white rail there, rail is in the harbour at Portland. They come in from time to time. These are gannets that crowded out the top of Lawrence Rocks, you can see in the distance. There's no room left, so they've started moving to the mainland. This is at the western end of Bridgewater Bay, where there's one of Victoria's largest seal colonies. You can see them there. But it's interesting when you look at that dramatic cliff behind it. That's an ash cone from the giant volcano that blew the whole bay out. So we're talking some pretty big stuff there. Very dramatic. I think that's Victoria's highest cliff. And then ultimately, this is the Bonnie upwelling along where the continental shelf is. It's very close to our Kanawinka coastline. All those red dots there are sightings of blue whales, which are reviving after being nearly eliminated 100 years ago by the whaling industry in the Atlantic and the Falklands and so on. Now they're monitored and protected. And one of the reasons why I also put this in is that when we were drawing up our proposed boundaries for the Kanawinka Geopark, I dotted the boundary lines out to sea. And UNESCO was scratching their head saying, oh, we've got nothing like that. Our geoparks are on land. What's this? And I said, this is a really important part of the geology of the region, where the platforms are and the continental shelf and where the currents flow, and it's all due to the landscape structures, and they got it. And not long after, they named a little geopark somewhere in the eastern Mediterranean, which is a little island in Greece with a drowned township out in the bay. So they thought that was a good idea. So, not wanting to keep too long, I'll just tick on through this. This is the cultural component that UNESCO require for a geopark. And that can be as broad as the activities of people. These are the Gunditj Mara people of the Budgebim Mount Eccles area, who now have a World Heritage Zone of their own because of all the eel trap culture that they had there. There's Damien standing. He's one of the descendants of the Gunditj Mara people, and those stone huts at the back were what they lived in. They've been dated back to about 7,000 years, dozens and dozens of them in little fixed villages. And this blew away the theory that all Aboriginal groups were nomadic. This was a settled community, and they could settle because the volcano lava had blocked up the river, formed a lake, and the eels from the sea would come in and they could trap the eels in the lake, and so they had a permanent food supply. And so that's what they've done. And the reason why he's standing in this little stone circle here is when Europeans started to arrive in those really rough early days, this down here was referred to as the Yumarella Wars. Some of the early stockmen and settlers would knock the huts down and just leave the foundation, take all the stone to build the dry stone walls all the way across western Victoria to enclose the land. There's a dramatic story in that alone that links the geology and the people. This is a very strange diagram. I've dealt with the huts below, don't worry about that. The blue is the sea, the other part is the land, and those two pointy parts are the promontories of Port Fairy. And this is a Kerep-Jamara's map of the land, the way they see the land, which is so different from how Europeans do. We see roads, mountains, various things like that, farms. They have a whole range of symbols for the resources or special sacred places and so on. I don't know how to interpret all of that, but they have their stories about it, which they're now starting to share with people. Just a culture with a completely different geographical outlook on the planet than we do. This is in the museum at Millicent, and those are replicas on fiberglass, life-size and accurately reproduced, of carvings in limestone caves scattered across the lower southeast. Nobody knows what they meant, but people started to recognise these and realised it was really important to record them. And then fortunately they are able to reproduce them as well. You can see some signs there and so on. They're quite subtle on the limestone. The limestone gets damp in a cave and they can gradually erode or be grown over by moss or algae and so on. It would be fascinating to know what they represent. Just above the signs on the left, where that little sort of orangey light is, there's a black lumpy thing in the wall. That represents flint layers that are embedded in the limestone, and that might have been one of the reasons they went to some of these sites so they could quarry the flint. Flint's a strange substance. Where you find it, there's a lot of it, but you don't find a lot of places with flint. But one of the places in Australia that's got a hell of a lot of flint is the limestone of the Limestone Coast. And they found flints from there traded right up into New South Wales. There's flints in the limestone of the Nullarbor Cliffs, which they found in the centre of Australia and so on. So flint would have been highly sought after in exchange for something or other else, and along these 1,000-kilometre song lines. Last couple of bits here. Europeans arriving in the Kanawinka region, they didn't know it as that term, although the word Kanawinka was around by that time, just over the border. This was in 1844, a watercolour of the Blue Lake, which is very interesting. I'm trying to match that with current water levels using photography. Not sure how accurate it is, but there's a couple of these other paintings that have been helpful of those factors. And Eugene von Gerard, who did beautiful painting of colonial Australia all over the place. That's the crater of Tower Hill at Warrnambool, with all the little volcanoes that emerged after the big one blew up and then calmed down. On the left, that's a map from one of Tennyson Woods' 2 books. He was a priest and he rode around the district on his horse for years, but he made scientific notes because he has 2 parts of his mind. We had a speaker here, I remember, who talked about his exploits in Indonesia and New South Wales and so on. So he was a product of the church, but his father had been an editor of the London Times at a time when science was really getting going, biology and early geology. So he was recording the landscape, and that was one of his maps where he identifies different things like caves and sinkholes and those ridges and dune ranges, and that got him thinking in his writing, these have got to be a lot older than the Bible. You could find old fossils and all sorts of things. So he was one of the forerunners of new science in South Australia. And the diagram at the top right here, that cliff edge, was done by Norman Tyndale in 1933 at Tantanoola, when they walked up that slope, found that little cave which had only just been discovered by some kids, and then they found another cave over the back, and they took fossil samples and things like that. The maps below are more recent, done by caves and cave divers, of the shapes of the caves, but Tyndale drew them in a profile. And then as Europeans settled in across the region, on our side of the border, they built out of the beautiful white limestone and that pink dolomite we've got. If I had the same photograph from anywhere on the other side of the border, the buildings would be that dark brown or almost blue colour. They call that bluestone, but that's basalt. That's part of those huge lava flows we talked about. They got plenty of it to quarry. Some beautiful work done with the soft Gambier limestone. This sculpture is done by a guy called Ivo Tadic, They're all across the region. I think he's retired now. I'm starting to document them. I'll put them in a little book, I think, to give credit. And I'm already in the process of nominating these for local heritage rating, because the locals say, oh yeah, that's the sea cells. You know, oh yeah, we've got those funny shapes. But we've got to recognise these are really, really symbolic of the region and this particular type of rock. And this is the Kanawinka Geopark. Geoparks have to have a broad appeal, and this being Australia, you have to have big things. So in Kanawinka Geopark, we had the giant wool bales at Hamilton. We had Australia's biggest red gum, which is the Bilston tree at Casterton. Down the left there is Hell's Hole, which is the biggest sinkhole of them all. I showed you a bit on the map. It's huge. And then we got Larry the Lobster, and who you can see from a plane when you fly to Mount Gambier, just walking up the beach. When I was a young fellow, they told me when that was built that apparently they ordered a 10-foot one and they got a 10-metre one. So I'm down to the last part of my talk, keeping an eye on my time so I don't keep us too late. But this is now to sort of tin tacks of what happened and what is happening. So we had Kanawinka Geopark that was announced in Europe at a conference by UNESCO in 2008, and everyone was very excited. By 2012, we'd received instructions from the Australian government that that couldn't continue. There's a 4-year, what's the word I want, a reassessment and renewal of the status of all geoparks, but the specialists who UNESCO were to send out here to reassess Kanawinka were told you can visit Australia but you're not allowed to reassess the geopark. So that stopped everything dead, and there are complex reasons for this, which we didn't know at the time. By that time we'd been going 4 years. We'd had a director of the committee for several years. That she became increasingly not as easy to deal with. And at some point we had to change, and I became the honorary director of Kanawinka Geopark, and then I had to deal with this news. Effectively, there are about 5 bodies of resistance to a geopark being set up in Australia. None of us on the geopark organisation had any idea this was going on. So what are these 5? One was the mining industry, who said, we don't want geoparks anywhere in this country because it's going to stop us digging, without even asking what the hell a geopark was and how we run it. Because they're basically just a community tourism thing, promoting visitation and the landscape and valuing it. So, mining industry, the big scale agricultural industry. And they were looking at areas across Queensland, Northern Territory, wherever else and so on, and saying, not in our backyard, thank you. So they were lobbying away and we were never aware of it. There was the national parks industry, who had seen this term geopark and made the assumption, again without ever talking to us, that we would be competing for parks money, which is not what we were ever about. Just ticking over in my mind, one of the other issues was that at that conference in 2008, everyone there was really excited because the first geopark was ever likely to be nominated in the Southern Hemisphere. That was Kanawinka. So there was a groundswell of approval before the conference started. I wasn't there, but there were some other Australians there, and nobody asked the question, is this supported by the Australian government? Eventually, when that drifted across the table, the answer was, yeah, that's fine, nobody's objected. Well, that's the wrong answer, because an arrangement between the United Nations and the host nation has to be agreed at least at ambassadorial level, and none of that work was done. Either out of ignorance or I think over-enthusiasm on the behalf of people here and people in UNESCO at the time. UNESCO's come a long way since then. So they named it, and suddenly Australia found that it had a geopark listed, the only one in the southern hemisphere, the largest geopark on the planet, number 57. You could put all the other 56 in one corner. They're all tiny across Europe and China and so on. And ours was half of Victoria. So another problem then was we had a geopark that was so big, 400 kilometres across, that the people in the Millicent end had no idea what was going on at the Colac end and how do you get them together and all those sorts of things. So there were a whole range of things that hadn't been anticipated. Something else was happening at the same time. Some of you might recognise that map. The federal government came up with a, sorry, is it working? Has it died? Oh, right, Lee, sorry, thank you. Is that one working? Oh, yes, okay. The federal government came up with an idea, let's have these things called Australian National Landscapes. Some of you might remember that term. And here they are. So some people in Canberra put red blobs on a map and said, let's have this system called Australian National Landscapes, and we'll put them in the hands of the Federal Department of Tourism and the Federal Department of Natural Resources, or whatever it was called at the time, which all sounded pretty good. They didn't know anything about UNESCO Geoparks. We didn't know they were doing that. This got publicity in national newspapers and so on to some extent. But it was one thing to come up with the idea and put out a map with coloured dots on it. It doesn't mean it actually exists. And within a couple of years, the feds realised unless they paid for it, it wasn't going to happen. So they handballed it to the states, who said, we're not touching this, we don't have that sort of money for a national program, and why should we spend the money on something that'll go to New South Wales or whatever else? Then it devolved down to saying, well, let's get the local communities to pick it up. And there was a committee for the Flinders Ranges one and others around the place. Not many, and the whole idea collapsed. Bloody great shame, because here we were being anointed as a geopark in an international system by UNESCO, roughly at the same time as this scheme. If the two schemes had come together, maybe something could have come out of it. But because of the resistance to the geopark movement that I told you about, we couldn't get any further. And part of the reason for that resistance is the name, Geopark. So a lot of people didn't want to know about rocks, and they assumed it was a mining thing without ever asking. And the idea of it being a park, is it a national park? What else it is? Does that mean our properties are going to have a boundary around them, we can't do anything anymore, we can't shoot the kangaroos off it and things like that? So the term geopark, which is really handy for nice little fountains and rock outcrops scattered across Europe, wasn't appropriate for a large mining and agricultural nation. So there's a big cultural gap in these things. You can see that it's not an easy situation. I did a lot of work over the years. I've wrote some things about the caves at Narracourt, the coastline of Victoria, a few other things. That book up there, Cave Diving in Australia, Pete there, my mate, he and I wrote that when we did the maps. We did the book about how to dive in caves without getting into trouble, and that became the Bible for the whole point. And on the right-hand side is a series of papers that I've had published in various international journals about the Kanawinka Geopark, and then heritage and Flinders Ranges and Geotrails, and then a review of the whole box and dice. So it's out there in the academic world being accessed by researchers. Then I had a look at the map. Where is it? Here it is. Here's our little map. If you unfold that, you end up with a map like that on one side. And I had a really good look and said, we're banned from being a geopark. We've done all this work. Everyone who was with us who'd put all that effort in was just horrified that how can it just be ripped away from us? So I had a really big think and looked at that map and thought, that map shows about 50 volcanoes with highways and byways leading to them, and caves and waterfalls and like coastline and so on. So there are trails already there. So why don't we go back somewhat towards the original idea of the Volcano Discovery Trail and pinch a bit of that? And so I looked around for geotrails elsewhere, and they were an emerging phenomenon nationally and internationally. In South Australia, we've got the Hyson Trail, which is brilliant because it goes all the way up the mountain chain. And in fact, for geologists, it's not just the red line there stopping at Lee Creek. The geology starts at the western end of Kangaroo Island at Cape Border and goes right through to Arkaroola, and then there's more to the north. And I thought, gee, you know, if we've got international or national geotrails, maybe we should be thinking about that type of activity. Then I looked a bit further and I found a map of Canada where they'd already started to do that. So they had a cross-continental geotrail network. You can see all these little ones pretty well joined up. And I thought, well, why the hell can't we do that here in Australia? And so I changed the name. So I changed the name on the map and did a bit of tweaking. And we printed another lot. So we became Kanawinka Geotrails, and it took all the politics away. Nobody was worried. The idea of geotrails, oh, we get it, that's fantastic. Nothing about mining and all the rest of it. It's not just that all disappeared. And that's what we've been ever since 2012. My last slide is what about geoparks? I'm part of a small group of the Australian Geoparks Network who are setting up some local geoparks in Western Australia with the backing of some of the shires. There's another group of them in New South Wales trying varying degrees of success. As soon as we crack one of these, we think UNESCO will be happy and the federal government will be happy. UNESCO want it to work. If the federal government's happy, then suddenly every shire will want one, or every local government. So I'm hanging on, and if I've contributed anything in this whole saga is I've kept the name Kanawinka and the concept alive. So thank you very much.